Hey everybody, I'm Zach.
And I'm Jesse.
And we've got a cool interview with you now with a company called Exro Technologies. We heard about them because they're working with Zero motorcycles to do something with their powertrain. We're going to try and get to that now with Josh Sobel, who is the CCO of Exro. Thanks so much for being with us today, Josh.
Hey, thanks very much, Russ. Good to be here.
Before we get into how this technology works, I just wanted to touch on your background so that you could kind of give our viewers how you know what you know.
Sure, yeah. So my background, I'm actually a mechanical engineer by training, and I started with General Electric early in my career working for one of their motor factories here in Canada, on the East Coast actually. Started there in an engineering program and kind of moved on to applications and sort of really working with customers and moving into that sort of field application engineering field. And from there, I joined actually Siemens after that. So again, in the same kind of field, electromechanical equipment, drives, motors, this kind of application analysis, this type of work. And from there, really, I met our CEO, Sue, through my career and joined the company last November. Came on. It was pretty exciting to see a technology like this. Looking forward to continuing to grow the company.
Interesting. Okay, so what is this technology that you guys at Exro are working on?
Right. So the best way I think I can sum it up is we've created what we've called the coil driver, and it's a way in which it's a type of inverter actually. So it's the motor controller that we've invented. That's a new topology of controller that can control different winding configurations in the stator of the actual machine. So we're able to basically change how the motor reacts depending on where the torque demand is in the machine and what the most efficient point where the motor can actually operate in is. And we do that automatically. We do that on the fly. And really that's part of kind of our trade secrets there is how we control that and the topology that goes behind that.
Okay, so up until now then, if I wanted to have a motor that did different things, I would need a gearbox that was geared differently, and I would switch into different gears, right? So like if I needed, to have a lot of torque and slow speed, I'd have like a first gear, and then I could go to second, third, and so forth, right?
Correct, yeah. So traditional, typically we're talking obviously about mobility applications, so traditional ICE type machines. You would need to actually have a transmission where you would take advantage of maybe a very short sort of peak torque or peak efficiency, and then you would switch gears and move up. Electric motors have the advantage where they do have a wider speed range. They have a better kind of torque profile that really fits the mobility application. But there are still limitations people are finding with electric motors even. And so because mobility applications have such a wide range of torque and speed requirement, they are now starting to go towards 2-speed gearboxes. So if you want high torque at a low speed, but you still need to get up to highway speed, what we're seeing is the market's looking at 2-speed gearboxes even. And so traditionally, yes, to get that full range and have it be optimized, you would have to go to either 2 motors, one that could be used for that high torque and one that could be used for the high speed, or you need to now go with a 2-speed gearbox. What we're essentially proposing is that our motor can effectively, and our controller paired with that motor can effectively create the same outcome.
Oh, so I get to ditch the physical gearbox.
This is our vision. Yes. That's what we see in the future, and I can kind of explain a little bit about the torque profile that we can create in the motor that will allow us to do that.
So before we get there, the advantage of ditching the gearbox is there's quite a few advantages. The first one would be you don't need to buy a gearbox. So cost would be probably the first one. Great. That doesn't belong in the bill of materials. Great. Chuck that out. Now we can lower the price of the vehicle, whatever it may be, scooter, car, whatever. Awesome. The next thing would be the gearbox is never going to break. So we don't have to worry, we don't have to stock those at the, service centers, whatever. Great. That's taken care of. Then I would imagine efficiency would be another because, again, every physical moving part creates friction and that slows down everything and that creates inefficiency.
And then weight.
Weight would be another one. Okay, so there's a lot of advantages of why you'd want to do this all digitally. A lot of reasons why, even if you just look at an electric car like a Tesla that only has one gear, there is the advantage because you don't have this big honking transmission with all the inefficiencies. But now you're able to actually put the gears back into it without putting the physical gears into it.
Yeah, you can think of if you're going to have an optimized machine, maybe we could even use a smaller motor as well to get the same outcome. So we can take a machine that might be given a different torque profile, and we can drive it harder for longer. So we can get a better torque at higher speed, as an example. And there's also a sort of a byproduct of this as well, is that when we switch the configurations, we get a different efficiency profile of the machine as well. So the motor actually operates at a higher efficiency at higher speeds when it's in one profile, and it operates at a higher efficiency at lower speeds when it's in a different profile or a different configuration.
Wow!
So you get a couple different advantages there, and so that's really the theory behind this, is that we'll have a system level effect on not only, like you mentioned, reliability, cost, but we'll also have that system efficiency overall. I'll really quickly note, we're not increasing the peak efficiency of the machine. We're expanding the area where it is peak efficiency.
That's a really good way to put it. So yeah, you're not making this, because electric motors are already pretty efficient on their own, but they're not efficient everywhere. They're not efficient at all RPMs at the same time, much in the same way that a car wouldn't be efficient if you only had one gear. And if you wanted to go 50 miles an hour, you'd have to start in fifth gear, and then you wouldn't start. But assuming you were rolling downhill very rapidly, and then if you wanted to go to 60, you'd just be redlining it. Like, it wouldn't be the most efficient way to do it. The same thing kind of with an electric motor, although it's a lot more forgiving.
Correct. Yes. Yeah. So there's still efficiencies to be had, but yeah, we're not. I just want to make sure that your viewers don't think that we're magically, redefining physics.
Okay, so we understand how motor controllers work here. Basically, you do pulse width modulation in order to, get whatever speed you want. So you're like on off, on off, on off, on off, on off, and the average of that is going to be 50% or something like that. How are you able to do different gearings?
Yeah, so I guess I would pull back from just your typical controller design and actually look at more the motor winding and how we change the motor winding. And so how a typical motor is wound. You've got Y, you've got delta type configurations. Typically, you've got groupings of coils within each phase. So if you think of a Y configuration, you've got some groups of coils, and those are basically what apply the waveform to the rotor. That then drives the mechanical output. Once we apply the voltage from the controller, that then converts into mechanical output. But those groupings of coils, they play a significant role in the actual torque profile of the machine, and how those groupings are configured can change the torque profile of the machine. So what we're essentially doing is we're connecting into the motor directly to those coils. So we are actually pulling leads from those coil groupings, and we are energizing them, I guess, on an individual basis in order to create different torque profiles within the machine. So there's a really big motor theory component to this that needs to be understood. And then the topology and the control of how you do the switch is the other component.
All right, just to dumb this down, it sounds like what you're talking about is the ability to magically switch between different types of motors to magically make the motor you need at this moment appear. And then when you're done with that kind of motor, being able to go, I'd like a different kind of motor to appear.
Is that?
Yes, essentially,
okay.
Yes. Yeah, I think that's one way to sort of like back it up and look at it.
And so then another thing is, when we're thinking about a motor, we're generally thinking about, a positive and a negative. Obviously, there's three-phase motors and stuff like that, but let's not get into that for now. With a motor that has a positive and a negative wire coming off of it, right? You're going to attach that to a battery or a motor controller, and that is what is going to be driving the unit. But what you're saying essentially is that you're not just taking the positive and the negative. You're actually rewiring the motor a little bit. You're going to, you're not necessarily ripping it all apart, but you're going to be connecting to the individual windings within the stator of the motor. Is that correct?
That's exactly right. Yes. And those connections are then made directly to the control device, the controller. And that's how we can basically manage and manipulate the torque profile and how those windings work within the machine.
So I can see now why, if I'm Zero Motorcycles, I would want to work with you guys, because you're talking about A, being able to get rid of my gearbox, my physical gearbox, and B, being able to get more out of my motor for the user to have a better experience, being able to get different gears and different torque profiles whenever.
And more efficiency.
Right.
Exactly, right. So interestingly enough, even when you don't have a gearbox and it's just a fixed gear, there's performance increases already. So we can play with what's called the turn count in the machine as well, and we can get different torque profiles that can be expanded and can provide higher torques at different locations as well. So if say, yes, that's sort of what we're doing with Zero, is to experiment with what are the different configurations that we can get and improve torque in certain areas where they were maybe lacking it and then maybe even sometimes we'll take away from other areas where they're not utilizing that torque, that piece of the torque profile as well. So it's sort of, there's a lever that we provide from a control standpoint that allows you to optimize your system, even if you don't have a 2-speed gearbox or something like that. You could, there's still this added level now that you can optimize your system, and that's kind of what we're playing with Zero right now to integrate into the SRS.
Now, what we talk about every week on the show is, how much more efficient cars have gotten, or how much, more energy density a battery has. But it sounds like in this case, it's not easy to put a number on what you're doing. Like, I couldn't just ask you, like, how much better did you make the Zero motorcycle?
No. And I would say still we're in the co-development phase right now with them. So I couldn't give you that exact number right now anyway. But what I would say is it is somewhat of a design decision, and so up front we have to look at the situation with the customer, look at what their challenge is, because some cars ultimately we're also working with a truck company now that's really interested because they frankly can't get the gradability from the trucks that they need. They can't get with the top speed without going to a 2-speed solution, and so they're really interested in this because we can drive their machine harder, and we'll be supplying a system to them as well by early next year. And the goal there is really to be able to provide increased performance in terms of the torque that they can operate at, which then obviously lets them put more load onto their truck and go up steeper hills and et cetera. So in terms of giving you that answer of just efficiency, it's hard to just say that that's all we do, I guess. From an efficiency standpoint, though, yeah, you need to also look at, is it weight? Is it torque at a certain point? Is it efficiency and how we design the motor? So I can't give you an exact value of efficiency at the moment, but we have done some simulations, and we do see the drive cycle efficiency can be improved by, it's not huge numbers. You're still single-digit percentages, but anywhere from 0.5% to 3%. There are situations where that can work. So, but it is hard for me to give you an exact number. I don't like throwing out exact numbers because each vehicle is typically different in terms of what they need. So I hope that answers your question.
Oh, absolutely. Yeah. I kind of want to go back in time to like the 1800s when Nikola Tesla is inventing the AC motor. He doesn't have computers, right? There's no way for him to kind of do this sort of technology where he could be, wisely changing the, which windings you're going to be, modulating at what times precisely. Pretty much impossible for him to do that. And yet the motor design that he created has basically gotten us all the way through up to this point with very little changes. And so this is, to me, I know that there have been huge breakthroughs in many different areas in terms of, lots of different very nitty-gritty things. But this is probably the biggest departure from Tesla's original design for the AC motor that I can think of.
I thank you. I like that.
I mean, yes, that is a compliment. I mean, this is
Yes, thank you. I appreciate that. Yeah. Yeah, I would say, obviously what he came up with, it's amazing. Not many inventions, I guess you're right, have that kind of longevity. First of all, I would say the mobility space right now is going through a monumental shift, and I don't think these types of shifts happen more than maybe once in a lifetime anyway. And there have been a lot of incremental improvements on the motor side. You're right. So there's different types of motor designs out there, but we're definitely going through this transition now. And there's obviously a lot of push from the market to see even incremental improvements. And a lot of that's been done on the motor, where I think you hit it on the head, where the computer, the digital ability to simulate, to change what the configurations might look like, and then control in that way is now becoming going to the forefront. So our view is that the motor topology itself and the structures of motors and the magnetic structures have been innovated a lot actually over the past 5 to 10 years, and we're trying to take it to the next level with the controller and start to play with the topologies of the controller, and how that paired with these motor improvements can then actually be that next step of innovation for the mobility sector.
Right. It's almost the next step after over 100 years of.
Right.
It's not stagnancy. It's just from the controller side, there hasn't been too much, and it's really exciting to think that, it wasn't necessarily that Tesla was just such a genius that he made the most perfect thing that couldn't be improved. It's actually really refreshing and kind of less scary to be like, oh, actually, you can improve upon this. We're not stuck. We didn't hit the top of the tech tree. There's more beyond this. That is relieving in some ways.
And for people who are watching who are like, well, this still sounds like magic. I mean, a lot of what Tesla, the company, was able to do was because they were able to start controlling motors more smartly.
Yeah, there's a lot of improvement that just went into standard controller design over the past 10 years. I think you hit it right. I mean, Tesla's the gold standard for EVs. I don't think anybody would sort of argue that at this point. But there's a lot outside of that now that's, they were definitely the pioneers in really pushing the shift. And I think now there's a lot of companies, and ourselves included, that are trying to push the limit even further. And I think, the controller design is something that we're really, really focused on, and really we think is sort of the next step in that, like I said.
If I was starting an electric car company right now and trying to compete with Tesla, I would need a lot of smart people to work with. And it seems like your company would be a company I'd want to reach out to get the best way to control my motor. So I know that you're working with a lot of companies right now. Can you tell us about some of those companies that you're partnering with? Sure.
Yeah. I think maybe I'll touch on a couple of the more recent ones, and we can go into some others if you guys want. But what we did was we essentially took a look at the market. When Sue started, she wanted to make sure that we were, very much focused on where the application of this made the most sense, and primarily look at it from a let's prove it out, let's get it into the marketplace, and maybe look at some niche applications where this makes sense. And what we found really was in the high performance type applications, there's definitely a need, first of all, for beating out your buddy who's maybe just got the standard type of machine, and that extra performance, especially at high speed, was a really, really good fit. So something like Zero Motorcycles or Aurora Powertrains, they need that kind of enhanced performance at a really high level. They want to go and be able to show that they can market the highest potential performance, highest torques, highest powers, etc. The other market that we looked at, and which we've just started a project, it kicked off with a group called C Electric. They're out of LA and Australia. Actually, they're in the middle of setting up in California. They do conversions of trucks. So what they do is they have agreements with companies like Iveco and Ford, and they basically convert those bare chassis and into electric. So they've got agreements with IKEA, FedEx, UPS, and those types of fleets that are trying to move over. And where this technology can fit was what I was actually kind of alluded to before, was where with that expanded torque speed capability, they can haul more, they can haul in different grades, and they can do it for longer. So for them, it was a cost of ownership type thing. So it was kind of finding these niches where we can prove out the technology and work with partners that really are at the forefront of what they're in their market. Zero is the classic example. I mean, they've been one of the motorcycle companies that clearly has proven they've got something, and they've been able to stick around and grow their company. And really, the new SRS SRF is flying off the shelves from what I understand. And so it's a business model that they've created, and they're always looking to innovate. So it was something that was exciting for us, and it was in that kind of niche where we really felt there was value for the technology. C Electric was the other one, and where I'd say there's that fleet focus, there's cost of ownership focus for us as well. That's another place that we can really show, and working with these companies is a really, really helpful on both sides. It's win-win. We make sure that when we do these types of co-developments.
So can you give us an example of how Exro's technology can save a customer money?
Sure. So I'll go back to the truck example. It's the most recent one. It's the most clear in my mind at the moment. But the challenge that a lot of these larger trucks are having is kind of what I described earlier, where often they're such high demand applications where they need extremely high loads, where they go from 20 tons, 25, 30 ton and above. Then they load up on either cargo, garbage, whatever, cement, whatever it might be. They needed a really, really wide range of, first of all, torque values that they can apply to their powertrain, but also in terms of speed. So it's a really good application where typically the only solution that's out there right now to really address that is a large, heavy-duty two-speed gearbox, or large dual motor type solutions, more expensive, basically, and higher maintenance style of solutions. If you can expand that speed range and also expand the torque that is available at different speeds, then we can eliminate some of those large components. And it's not just that you're eliminating a gearbox, you're eliminating, as you mentioned earlier, you're eliminating maintenance. So if you have a fleet of vehicles that needs to be out, the lower the maintenance cost, the better the cost of ownership, the sooner the return on the asset. You're also eliminating a lot of integration costs. You don't need all the control around switching the gears, and that's sort of the brains behind actually when do I switch and how do I switch, and what sort of, is it electrically actuated, is it pneumatic or hydraulic, whatever it might be. All of those components just go away, and less components increase reliability, they lower cost. And so from that standpoint, you can see from a system level, having this added lever of control and capability can deliver benefits throughout the vehicle and throughout the powertrain, not just to say the motor efficiency, for example, which is one, but there's more to it than that. So on a system level, we do see quite a significant impact just by using this technology for that application as an example.
That's interesting. Now, I know a lot of our viewers watching are always emailing us asking, Zach, Jesse, what are the companies that we can invest in that are part of this new future? Turns out Exro Technologies is a publicly traded company. Is that correct?
That is correct. Yes. Yeah.
So we're not going to get bugged by a lot of people like, how can I get in on like a seed round, guys? You guys can go out there, and if you want to check out the company, you can buy it with your local broker, right?
Yep. Yeah. You can go on. So we're on the Canadian exchange, and you can also buy us through the U.S. exchange as well. But you should be able, just through your broker, be able to find some of your online brokers. You should be able to look us up, XRO.
Now, Jesse, I know that you probably want to geek out a little bit more on the technology behind it. Whatever you can tell us without, having to kill us. How does this technology work? Can you give us a little bit more behind the scenes?
To go a bit deeper into the technology, what I'm able to say is effectively what we're doing is we're changing the inductance of the machines, and so inductance is the tendency of a coil to resist a change in current. And that's as technical as I want to go, but effectively when we switch from those configurations, we can, at a higher speed, we can reduce that inductance. So the impedance in the stator lifts by roughly 75%. And that just gives us more voltage at a higher speed to be able to drive the machine to higher torques and higher power, and also to higher speed. So less of the voltage from the controller is being used to overcome that inductive load, if that makes sense.
So I kind of want to analogize this a little bit, just so that way for people who are watching, who are then going to go, talk to their grandfather or father and try and explain this to them.
Or the other way around.
Or the other way around. It's very well maybe the other way around. If the electric motor was the gas engine, is this technology kind of like the fuel injector?
Oh, interesting question.
Because we're kind of cheating a little bit. Is it the turbo supercharger? Is it all three?
Actually, yeah. I think in your first video you called it the turbocharger, and I think there's a fair comparison there. You can think of you're kind of getting more out of the machine, but it's the same sort of fundamental architecture of the engine, let's say. But what we're doing is we're applying a technology that'll provide more out of that. It's obviously it's not a thermodynamic phenomenon; it's an electrical phenomenon. But right. I would say, yeah, I like the analogy maybe, and I don't want to get in trouble for it, but I would say, yeah, the turbo or the supercharger, that sounds perfect. Yeah, that sounds great. So.
What's your take on this whole electric revolution? I mean, you're kind of in the middle of it, and we love to hear from people who are actually doing this stuff. We're kind of seen as outliers where we think that, there's going to be a very quick adoption of EVs. But what are your thoughts?
From my perspective, personally, I see a global push of a generation that wants to see a change. They're not aspiring now to get the V8 or the turbocharged engine. I don't want to make generalities, but if you're under the age of 40, it's more likely you're probably looking up more articles about Tesla and electric vehicles and the Porsche Taycan than you are maybe looking at the next V8 turbo or whatever it might be. So if you're a car enthusiast, I think there's a bit of this generational shift that's happening. What I think is the bigger push, actually, from a automotive investment standpoint, again, my personal opinion, is the policy changes now that are coming out. A lot of what's happening in Europe is going to make it difficult for automotive companies to justify investing in gas engines. And the more that they push to invest in electrical, the more they're going to have to prove that it can be done and that they need to adopt it. And I think the choices for ICE style powertrains are going to be more and more limited. I think what's been interesting about the current situation too, I'm obviously referring to the pandemic, is governments taking this time or taking this opportunity to try and shift the economy and try and shift people's training to this type of technology. We haven't really seen a slowdown of interest through this bout, but I know that in other sectors there's been a serious hit, and that we should take that seriously. But we have this new industry that's upcoming where I do think you're going to see an accelerated growth. It might only be that there's a couple million electric cars a year right now of the 100 million that are typically built. But I don't think anybody is saying that's going to slow down. That's only going to really increase. Just the investment now needs to be justified, and the policy is really pushing it. And there's the market acceptance, I think, now as well. So I'm firmly in your camp, where I think this electrical kind of revolution is not really going to slow down. And I think we're going to see a real bigger interest from even older generations that might be nostalgic about those engines once they see the performance that can be had with the electrical powertrains. So we're excited to be part of that, obviously, and we're excited to move forward.
So what is the future for Exro Technologies?
Very good question. So our view here is to continue, obviously, developing the technology. We want our technology to be driving around cities and towns and between towns and cities in some of these niche markets. But our end goal is obviously to develop partnerships and develop contracts with larger automotive companies. And the more that we refine the technology and the more applications that we can get into, that is really our long-term goal. So Exro can provide controllers, and we work with motor partners. We can provide systems right now, but our end goal, I would say, is really to be having our technology mass produced in the automotive sector. So our goal is to really push incrementally towards that, and like I said, develop and refine the technology and other complementary technologies around it, using the coil driver really as our anchor for that. And I see a bright future, I guess, ahead. That's what I can say.
Nice. Well, I can't wait to, coil driver a Tesla, a hot-rodded, Tesla. Like, 0 to 60 in 2.1. Well, how about,
Well, that brings up a really good point. Like now, if you're a hot rodder, you can go get something to add to your engine like we talked about. But it seems like in the very near future, you would be able to hot rod one of your electric cars with better technology from another company.
Right, because, we've seen conversions of electric cars and stuff like that, and I don't want to say that they're boring. They're obviously more exciting. They're, in many cases, faster and better, but there's less tinkering that can be done. And I feel like this will add the tinkering that so many people are going to be missing with their old gas car, that maybe they could be noodling around on their laptop even from their couch, and then updating the motor controller to something that would work even better. But it's really exciting that we have moved beyond, the basic AC induction motor, and we're moving on to a brighter future with even more control and technology. So thank you so much for working on it, and thank you so much for talking with us today.
Yeah, absolutely. Yeah, thanks for having me.
Thanks so much for watching Now You Know. We work hard to bring you videos about things that we think you'll find useful, but we need to know from you what you want to see, so leave your comments below. Also, don't forget to go over to our Patreon page, where for as little as $1 a month, you can watch our Patreon bonus story every week on Tesla Time News. Thanks again. We'll see you soon.